Hi everyone, it's Mrs. Guffrey. Today we're going to be doing a math lesson, and what you're going to need if you look at the bottom of your screen is paper and a pencil or a pen, because even though we can't talk to each other, I want you to be doing the work with me. Okay, so today we are learning that mathematicians look for patterns when solving word problems, but we're not just going to be looking for patterns. We're going to be thinking about why do these patterns emerge as we go. Today, in our lesson, we're going to be thinking about Monty. So please watch this video.
So Monty, Monty loves doggy treats. He can only have a half of a doggy treat at a time. So I'm only going to give him half of this doggy treat so he doesn't get an upset stomach. Monty, can you shake? Can you shake? Shake. Good boy. So we're going to be thinking about Monty's treat and how he only gets half at a time.
Okay, so let me find my tab here. There we go. Okay, so like I said, we're going to be thinking about Monty and his treats. So I want you to imagine that I have 5 treats and I give Monty a half of a dog treat at a time. How many times can I give Monty a treat? So we want to think here, what do I know and what can I draw? So I want you to pause the video. I want you to read it again one more time and think to yourself, what do I know and what can I draw? And make sure you label your drawings. Okay, so I have 5 boxes here, and each one of these boxes represents one treat. So I want to make sure that I label my work. Okay. What else, though, do I know from this problem? What do I have to do to each of the dog treats? Well, Monty doesn't get a full dog treat. He only gets half at a time. So I'm going to go and I'm going to cut each of my dog treats in half. What do you think is a label that I should put in? If you're doing this with me, I would like you to pause the video and go ahead and draw in your labels. We know that each one of these pieces is 1/2, and that takes me a little too much time to go through, but I would want to go through and label each of these. As a mathematician now, I'm thinking, how many 1/2s are in 1? And if I look at my picture up here, I can see that there is 2 1/2s in 1. So if I know there's 2 1/2s in 1, then how many 1/2s are in 5? Well, I can look at my picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who else got 10? So I can give Monty treats 10 times. I want you to think for a second. How does knowing how many halves are in 1 help you solve how many halves are in 5? So now that I have my picture, I found my answer. I want to think though, what equation matches this picture? So let me think here. What do I know? Well, I know I have 5. And I'm thinking, how many halves are in 5? Well, I'm actually taking those treats and I'm cutting them up into half-size pieces. So then how many times can I give Monty treats? I can give him 10. Now, we're going to keep going, but I want you to think, why is my answer bigger than my whole that I started with? I want you to think about that as we go on. Okay. Second question. Now imagine that I don't have 5 treats, I actually have 10 treats, and I give Monty half of a dog treat at a time. How many times can I give Monty a treat? So again, I want you to pause. I want you to think, what do I know? What can I draw with labels? And then think, what does this picture tell me? Okay, so I'm sure you have 10 boxes. Again, we want to make sure we label. Each of these boxes represents one treat, one full treat. And what do I know about the treats that I give Monty? Well, I know I cut them in half. So I have to go and cut each of my boxes in half. So let's think again about the question we asked ourselves in the first problem. How many halves are in one? Did you think how many halves are in one? Let's think. Okay, we know, we know that there is 2 1/2s in one. So if there's 2 1/2s in one, how many 1/2s are in 10? And we can look at our picture and see that. I see 20 1/2s, and you should have these labels in your boxes, just like I do, but filling in all of them. Our labels are important. So we can see here that Monty would get 1 treat here, and then another 1/2 of a treat here. So how many times does he get a treat? 20. And what equation matches that picture? Go ahead and pause and write the equation that matches. How many of you have 10 divided by 1/2 equals 20? And remember, when we read this, we can actually read it as how many 1/2s are in 10. There are 20 1/2s in 10. Okay? Let's take a look at what we know so far. We know that 5 divided by 1/2 is 10, and 10 divided by 1/2 is 20. Okay. For our third problem, now I want you to imagine that I have 12 treats. But I decided 1/2 of a treat is way too much. So this time I give Monty 1/3 of a dog treat at a time. How many times can I give Monty a treat? I want you to go ahead, pause the video, but before you pause it, I want you to think, what do I know? What can I draw with labels? And what does my picture tell me? Make sure you draw an equation that matches. Pause. So this time we have 12 treats, but I'm not giving Monty 1/3 or 1/2, I'm giving him 1/3. So I want to think to myself now, how many 1/3s are in one? Well, I know there are 3 1/3s in one, because I know that if this is 1 treat, I'm cutting it up into thirds, there's going to be 3 pieces. 1/3, 1/3, and 1/3. Okay, so I now see there's 3 1/3s. So if there's 3 1/3s in one, how can that help me solve how many 1/3s are in 12? Can anyone think of an equation that matches that? I'm wondering if some of you know it's 36, because in your head, well, if one group has 3, but you have 12 groups of 3 1/3s, that answer gives you 36 times you can give him a treat. Okay? And so then we're going to think, that would look like all of these then cut up into thirds if I were to cut them all up, because there's 3 1/3s here. What division statement matches this one? 12 divided by 1/3 gives us 36. Or there are 36 1/3 in 12. How many 1/3 are in 12? So mathematicians, oops, what just happened there? Everything kind of moved. Went back one screen. I want you to think, as we look at this, our past problems, we know that 5 divided by 1/2 is 10, because there's 10 1/2s in 5. 5 divided by 1/2 in 20, because we know there's 20 1/2s in 10. And then 12 divided by 1/3 is 36, because there's 36 1/3 in 12. I want you to think to yourself, why is the answer a larger number than the whole we started with? And what patterns are you noticing as we are dividing a whole number by a fraction? Okay, this is what I would like you to do. On SeeSaw, I want you to answer these 3 questions. Number 1, Jane bought a 4-pound bag of sugar to make cookies. Each batch of cookies called for 1/4 cup of sugar. How many batches of cookies could Jane make? I want you to make sure you draw a picture, an equation that matches that picture, and I want you either to explain your work in writing or by recording your voice. Number 2, I want you actually to create a word problem that matches the following equation: 14 divided by 1/3. And number 3, look back at question number 2. Why in number 2 was your answer greater than 14? You guys are doing a great job, and I can't wait to see your post.